All right, so chapter 3, we're going to talk about compounds, different compounds, ionic compounds and covalent compounds to be exact. And we're going to talk about the types of bondings, ionic bonds and covalent bonds. So this is kind of the outline again. We'll first talk about different classifications and properties of matter. So a homogeneous solution, a heterogeneous solution, some properties. We've already talked about physical properties and chemical properties. We'll go over them a little more quickly since we've already talked about it in lab. Then we'll talk about the different types of bonding. So ionic bonding first, and the different types of compounds that ionic bonding makes. And then we will talk about naming the ions and naming compounds. Then we'll talk about covalent bonding and molecules that they make and naming molecular compounds. We'll go a little bit more into the ionic bonding and talk about polyatomic ions. And then we'll talk about acids, and then this kind of review at the end. This chapter is not hard. There's a lot of information that you kind of have to memorize and learn, in particular naming and writing compounds. So you just kind of have to do a lot of problems and do a lot of practicing, and it's really not a lot of information. All right, first of all, let's classify compounds. All right, compounds can be classified as a substance, that means a single substance, okay, or a mixture. So a substance is a form of matter that has a specific constant composition, universally constant composition, and distinct properties such as color, taste, and smell. All right, so an example of a substance could be a particular element like gold. All right, gold has a set of properties. All right, it has like a yellowish color, it's kind of shiny, it's very expensive. That's not really a physical property of it. That's, an economical property, but it's still a property. And has a certain amount of protons and neutrons and electrons. It has a certain color to it. It has a certain smell to it. I presume it has a certain taste to it. All right, water is another example of a substance. It doesn't have to be a particular atom. It could be an actual molecule. All right, water is clear. It really has no taste, no smell, and so forth and so on. All right, and then you have a mixture. Before we get to this, this is a little bit out of order, so let's go back. So we'll just kind of go out of order. The other one is a mixture. Okay, so a mixture is a combination of two or more substances. Okay, like salt water is an example, or saline. All right, saline is a mixture of two pure substances, sodium chloride and water. Okay, pretty straightforward. All right, and then you have two types, homogeneous or homogeneous and heterogeneous. Homogeneous is where everything is mixed together and you have a uniform mixture, all right, such as if you take sugar and throw it into water, or salt water, it's uniform. Right? Heterogeneous is where you have two or more things put together, but you can see them, you can see each individual component. It's not uniform. All right, like oil and water. All right, oil floats on top of water. You can actually see them. All right, Italian dressing is a perfect example. There's so much stuff in there. All right, it is a mixture, but I would consider that a heterogeneous mixture. Okay, um, and then with these, you have three different classifications. You got a solid, a liquid, and a gas. All right, solids, they kind of show you the atomic view. Solids is where they are closely packed towards each other with very small movement. Okay, so close and virtually no movement or very little movement. Okay, where liquid, you have a little bit more space, so you can kind of see there's a little bit of space in between them, and they vibrate a little bit faster. Okay, they're close, but not as close as a solid. And then finally, you have a gas where you have lots of area in between all of the gas molecules, and they are moving very quickly. All right. Um, so this is kind of how you classify properties. All right. So there's a quantitative way to classify properties and a qualitative way. Okay, a quantitative way is where you express it with numbers. Quantitative, quantity. All right, that's where the word quantity comes from. Okay, so a measured or expressed with number. Like I have 5 grams of gold. Okay, there's a quantitative part. Let's put here 5 grams of gold. All right, the quantitative part is I have 5 grams. That technically is a property because I can have 100 grams, I can have 1,000 grams, I can have 1 atom. All right, that's a quantity. The qualitative is where you don't express a measurement. So it's more like the physical or the chemical property of it, which is what we're going to talk about down here. Okay. So let's talk about qualitative properties. So one is the physical property. Now, again, we've talked about this, but we'll talk about it again. These are properties where you observe or you measure something without changing the identity. Okay, so the color. Okay, gold has a yellowish color to it. It's a little shiny. It's hard. Okay, it has a particular melting point. It has a particular boiling point. It has a density. All right, gold has a pretty high density to it compared to water. Or whatever the physical state is. Is it in a solid state, a liquid state, or a gas state? Okay, melting is a physical change or a physical property. I'm not changing the identity of gold. It's still gold. Like if I take water and I boil it, all right, if I take water as a liquid, all right, that's supposed to be an L there, and I boil it and I turn it into a gas, all right, and it took me 100 degrees, it took me to get to 100 degrees Celsius to do that. That's a physical property. I haven't changed the identity of water. It's still water, all right? It's just that now it's in a gas form, physical property. Now, a chemical change or chemical property is the exact opposite. It's a property where you do have a change in the identity. Okay, so for example, iron, when reacted with oxygen, oxidizes to form rust, which is iron oxide, Fe2O3. That is a chemical property of iron. Physical property, it kind of has like a brownish red color. It has a density, has a pretty high density. It's usually a solid at room temperature. It's got a particular melting point that's extremely high, but it turns to rust in the presence of oxygen. That's a chemical property. All the other ones are physical properties. Okay, so let's kind of go through this and kind of talk about, are we talking about a pure substance or are we talking about a mixture? All right, the aluminum in a soda can. What do you think, pure substance or mixture? All right, I hope you said pure substance because aluminum is pure. It's not a mixture. Okay, a sports drink like Powerade or Gatorade. All right, well, that is going to be a mixture. It's mixed. There's salt in there, there's sugar, there's water, there's flavorings. All right, if you look on the back of the bottle, you will see all the things in Powerade. It's not, just a few ingredients. It's actually quite a bit. Salt. All right, salt is sodium chloride. All right, well, that's a pure substance because it's just salt. It doesn't have to be just an element. It could be a mixture of elements, but if it's just one thing, it's a pure substance. Finally, carbonated water. What do you think carbonated water is? Well, it's actually telling you there are two different things in here. Carbonation is carbon dioxide, and you have water. So this would be a mixture. Okay? Simple as that. There's no tricks to this. That's basically all there is. Okay? Okay, we're actually going to pause here as this video because it's going to take a lot more to start talking about these ionic compounds. So when we come back in video 2, we will talk about section 3.2.